Question number 21. A circular coil of radius r and mass capital M placed so that it touches a step height capital R as shown in the figure. The minimum value of the horizontal force required to pull the coil over the step is. We have to find the minimum force. The diagram is like this. Minimum horizontal force is F. Radius is given as R. This height is also R. Now there are two forces on object. Weight is capital Mg and F horizontal force given by pull. Then pull the coil over the step. Reaction at this point should be 0. Therefore, I have not marked the reaction. For pull the coil, the torque around O in this direction should be equal to equal to the opposite torque. We can consider torque in this direction, mass mg into weight mg into perpendicular distance from O is R should be equal to opposite torque F into perpendicular distance also R. That perpendicular distance between action line and O is R. Therefore, we can cancel out R term. F equals mg. Third answer is correct for the question number 21. There are question number 22. A figure F1 to F8 drawn to scale act on the point object O as shown. They have not the question. They have not given the question. Question should be the resultant force. We have to find the resultant force of the object. Then we can cancel out forces. I will draw a rough sketch. F5, F1, F6, F2, F7, F3, F8 and F4. When considering resultant, we have to remove this length and same length from this line. We have to remove this part. This length and same length from this line. This length and same length from this line. This length and same length from this line. Now, we can consider there are four forces like this. Now we have to get the resultant. We can consider first two forces. The resultant should be in this direction. And the magnitude of diagonal is represented in the resultant. And for the resultant and this force, we can draw another parallelogram. You have to get only the method. We can't get correct answer because of this diagram is not the original diagram. And we have to get again a parallelogram like this. then resultant of the system should be in this direction. We can get it as OC direction. Third answer is correct for the question number 22. Question number 23. Figure A, B, C and D show 4 ways which a light spring balance can be loaded with a weight 100 Newton using frictionless pulley. The scale reads readings of the spring balance in 4 cases would be. The spring balance reads the tension of the cord. All 4 cases, tension of the cord is 100 Newton. Therefore, we can get that answer for the question number 23 is 1. The tension of the cord is not depending on the angle represented in figure. Therefore, all tensions should be 100. Then 24. Figure A and B show 2 ways in which a painter could use a system consisting of a platform P, a pulley and rope in painting tall buildings. The total weight of the painter and the platform is 400 Newton. If the rope is light, then the tension of the rope in 2 cases are. In the first case, they have given a figure like this. Now, total weight 400. There are 2 tensions. Same tension because of there is the same rope. Then we can get vertical equilibrium. 2T equals 400. T equals 400 divided by 2, 200 Newton. In second case, the diagram is like this. Now, this tension is balancing total weight 400. Now we can consider vertical equilibrium. T dash equals 400. There are 2 forces. Then 200 and 400. Answer 3 is correct for the question number 24. Question number 25. A system of coplanar forces OA, OB, OC and OD, OC, OD, OE and OF acts on an object as shown in the figure. The magnitude of OA equals 2 OD, OE equals 2 OB. The resultant force of the object is mostly like to be. I will draw the rough sketch. OA, OB, OC, OD, OE, and OF. Now they have given OA equals 2 OD. Then we can cancel out OD part 10. We have to get a force like this. Half of line. Then OE equals 2 OB. OE equals 2 OB. Then we can remove OB and we can get half of OE. Then we can get the resultant. I will consider these 2 forces. We can draw the parallelogram. And resultant is like this. We can remove these 2 forces. Same method, we have to draw a parallelogram like this. Resultant is this one. Now there are two forces. We have to draw the parallelogram like this, and resultant is this one. Then it is approximately along the direction of OC. We can get it as OC, in OC direction. Then answer is 1. We can't get the correct answer because of it is not the original diagram. Then question number 26. A thin disc has freedom to rotate around that axis, passing through its center O, perpendicular to the plane of the disc. The disc is acted upon by given 5 coplanar figures, coplanar forces 1 to 5, equal in magnitude as shown in the figure. Consider the following statement made about the torque produced by forces. Statement A. Minimum torque is produced by force 2, F2 force. Yes, no. It is incorrect because of F4 is passing the center. When considering F4 force, it is passing the center. Therefore, minimum torque should be represented given by the force F4. A is incorrect. Then B. Rotation of the disc due to resultant torque will be clockwise direction. We can consider that F2 and F1 forces are given a clockwise torque, but F5 and F3 counterclockwise. When considering the torque due to F1, we can consider that it is approximately equal to F3, and the torque due to force 5 is greater than force 2. Therefore, there is a counterclockwise torque. Therefore, it is incorrect. The system is rotating counterclockwise. Part C. When the magnitude of forces are double, the magnitude of torque will also double. Yes, we know that when magnitude of force double, torque is Fx. When force doubled, torque also doubled, directly proportional. C is correct. Only C is true. Then answer C is correct for the question number 26. In question number 26, also we have to consider the perpendicular distance. Sometimes in the given figure, some perpendicular distances will different than the original diagram, original paper. Therefore, according to given figure, we can consider that the answer is 3. Question number 27. A man of mass 60 kilograms standing on a uniform wooden rafter hung horizontally by 2 identical ropes is painting a wall. The mass of the rafter is 20 kilograms. What is the minimum tension that should be withheld by each rope so that man can move safely between A and B? The minimum tension that should be withheld by each rope so that the man can move safely from A to B. If the man is at point A, now there are two weights. Weight of mass 600 Newton, it is 60 kilograms. Weight of the rafter 200 Newton, it is 20 kilograms. Now tension of A is maximum, TA. Tension of B should be minimum. For this considered situation, the man is at point A. Then I will consider torque around point B. Counterclockwise torque 600 into L, weight into perpendicular distance, plus 200 into perpendicular distance L over 2 should be equal to TA into L. We can cancel out L term. 600 plus 100, 700. TA. Tension at A should be 700. Now, it is the minimum tension withheld by tension rope A. By considering same thing, if the man is at B, tension at B should be 700. It is the minimum tension required for the rope B. Minimum tension means the rope could be given a tension greater than 700 because of he can move from this point to this point. If the tension, if the rope could not be given this tension, the rope will break when the man is at this place. Then answer is 4 for the question number 27. Then question number 28. If three coplanar forces 20 Newton, 40 root 2 and 30 root 2 act on a particle situated at the origin O of XY coordinate system as shown in the figures, the vector that represents the force necessary to keep the particle stationary is. We can consider components. I will get Y component. There is a 20 force in upward direction. It is Fy. And 40 root 2 cos 45 in upward direction. We know that cos 45 is 1 over root 2. I will substitute after the first step. And there is a downward force 30 root 2 again cos 45. Now we have to simplify. 20 plus 40 root 2 cos 45 is 1 over root 2 minus 30 root 2 cos 45 is 1 over root 2. 20 plus 40, 60 minus 30, 30. It is the vertical upward force. And then we can consider horizontal force. I will consider Fx. 40 root 2 sin 45 plus 30 root 2 sin 45. Again we can substitute sin 45. 1 over root 2. 30 root 2 sin 45 1 over root 2. Now 40 plus 30, 70. Then, when considering these two forces, this force is 30, this force is 70. Therefore, resultant should be in this direction. We have to draw the diagram. They have given upward 20 Newton force is represented by two small squares in the diagram. Therefore, we have to get 3 squares to represent this force and 7 squares to represent this force. Like this. And we have to get the correct direction OC. Then answer is OC direction. OC is like this. OC. Then answer is 3 for the question number 28. Then question number 29. A bull fastened to strong tree with a rope, attempting to eat a nearby coconut plant, is shown in figure. Figure A. The free body diagram of the bull is correctly represented by. We have to draw the free body diagram. It is trying to move in right hand direction. Therefore, it should give a force on earth to the left hand direction. Therefore, an opposite force is acting on legs, and there is a reaction on the legs due to the earth, and weight of the bull is in downward direction. There is a cord from neck, and therefore there is a force opposite to the movement. Then we can get the answer is 4 for the question number 29. Then 30. There is a diagram like this. The pulley arrangement shown in the figure exerts a force on a leg of a patient connected to a traction device D. The pulleys are frictionless and system is at equilibrium with the horizontal force acting on leg D is 80 Newton. Then value of the hanging mass will be, they have given 30 value. Hanging mass is this one. It is equal to tension. Therefore, we can consider there is the same rope like this. This force is 80 Newton, it is given in the question. If this weight is mg, tension should be mg. Now we can consider the horizontal equilibrium of pulley. We can write mg cos theta. This angle is theta, therefore horizontal component is mg cos 30. Not theta, it is given as 30. mg cos theta is horizontal component for this force, and there is another component, same component, we have to multiply by 2. 2 mg cos theta equals 80. 2, we have to find m value. G 10 cos 30 is given as root 3 over 2 equals 80. We can cancel out 2 and 2, 0, then m value is 8 divided by root 3. 8 divided by root 3. Then answer is 3 for the question number 30.